This is the sampling homework with Excel. So the sampling chapter is just like that chapter 3. Hold on a second. So this chapter, the sampling, is strongly related to chapter 3. Let me get back up there with the z-scores and what's the probability of finding, a z-score, something like that. These two are basically the same thing with one major exception. With sampling, all you do is you divide the sample size, you divide the standard deviation by the square root of the sample size. That's what sampling means. Okay, so let me do this homework sheet for you. Hold on. All right, here's the homework sheet and the Excel. So this first one is probability that a sample is greater than some number. Okay, that's this formula, equals norm dist, no s. This is greater than some value, and this is 1 minus, and this is between some values. So I'm going to go ahead and pick this cell right next there. I'm going to go ahead and type this in with the information. So this tells us right here that the distribution is normal. That's what the big N means. And the first number is the mean, and the second number is the standard deviation. And each different problem has a different sample size. So give me a second. If you start typing equal norm dist, it'll pull it up anyway. Go ahead and pull that one up. So our problem is 60 for this problem number 1. And the stated mean was 52. Standard deviation is 14. Now we have to divide that standard deviation by the square root of the sample size. So if the sample size 1, square root of 1 is 1, so we really don't have to, but let's put it in there because the rest of them, I'm simply going to cut and paste this formula and then change what we need to change. And in the cumulative, we always just pretend it's true. Close parentheses, enter. So there's the probability that it'll be under. Remember, if we don't put a 1 minus up there, this is what the probability of grabbing one apple under 60 grams. So we want over, we got to go up here and type in 1 minus that whole mess. Okay, so there's the probability of that one right there. You make it big, pretty. Do away with a couple of the place values. And let's stick to 4 place values. That's what most books do, and we're going to center it. And I'm going to put little borders around it. Okay, what I'm going to do is I'm going to Control C, and then I'm going to paste it in each one of these boxes down here, just as a shortcut. Okay, but that's the answer to number 1. Number 2, 4 apples. You'll notice that the sample size changed to 4 is less than 45 grams. So we don't need this 1 minus because less than is what naturally comes out of these things. But now we're going to change 60 to 45. 52 stays the same. 14 stays the same. But now we got to take the square root of 4. Square root of 4 is 2. And we just hit enter. So there's the probability that you would get 4 apples where their average weight will be less than 45 grams. So that's about 15-16%. All right, so we're going to do the same thing here. This is a betweener. So we're going to go up here and get rid of the 1 minus. Right, we're going to follow this bottom one down here. Probability that X is between A and B. So we're going to simply put a minus sign, repaste. So we want the big number first. So 52. Right? Means 52. Standard deviation is 14. And we're talking about the square root of 100 this time, which is 10. You'll notice I'm using nice, neat numbers. And then the second one is going to be 50. 52, 14 divided by, again, the square root of 10. And that should give us the probability. Boom. So there's about a 42% chance that 100 apples will have a mean weight between 50 and 52. Last one, 1,000 apples have a mean weight more than 52.1. So we're going to leave the 1 minus up there because it's a greater than, more than. And this becomes 52.1. And now we got to figure out the square root of 1,000. Hold on. I think it's around 31 or something, but we're going to do it the right way. 1,000 square root 31.7. Let's just call it 31.7. So we're going to divide 14 by 31.7. The rest of that is true. So there's your probability right there, that the 1,000 apples will have an average weight of those 1,000 apples will be greater than 52.1. So, and again, 52 is the mean, so you should expect that to be close to half, and it is. Okay, so that's how you do this one. MGZ, out.